Hemocytometer with improved Neubauer counting chamber. Hemocytometer is an instrument used for counting the cells in blood or fluid. It consists of a special instrument called the counting chamber, cover glass, pipettes for diluting the blood, rubber tube with plastic mouthpiece for drawing blood or fluid in pipette. The blood is diluted with appropriate known volume of diluting fluid, and then counting is done by using the hemocytometer. Improved Neubauer counting chamber is a thick glass slide, the center of which has a double ruling area separated by troughs. It is a thick crystal slide with dimensions of 30 into 70 millimeters and 4 millimeters thickness. The central part where the counting grid has been set is where cell counts are performed. The chamber has two counting areas that can be loaded independently. Each counting grid is 3 into 3 millimeters in size. The grid has 9 square subdivisions of width 1 millimeter. The 9 main squares of the counting chamber are delimited by 4 lines. The frame of the counting chamber consists of 9 large squares, each with a 1 millimeter square area. The squares placed at the 4 corners are used for white cell counting. Since their concentration is lower than the red blood cells, a larger area is required to perform the cell count. The large central square, which can be seen in its entirety with the 10x objective, is divided into 25 medium squares, which can be seen with the 40x objective. Each one of the 25 central squares is subdivided in 16 small squares. Therefore, the central square is made of 400 small squares. The central square is used for platelets and red blood cell counting. Glass cover. A special cover glass is used which has a very smooth flattened surface and even thickness. It is a squared glass of width 22 millimeters. The glass cover is placed on top of the Neubauer chamber, covering the central area. The glass cover leaves room for the cell concentration between the bottom of the chamber and the cover itself. The chamber is designed so that the distance between the bottom of the chamber and the cover is 0.1 millimeters.
So the next video will talk about how this instrument or equipment called hemocytometer is being used to count white blood cells and red blood cells. So sit tight and enjoy yourself.
Total leukocyte count or TLC by improved Neubauer chamber. WBC count is a blood test to measure the number of white blood cells or leukocytes in the blood. There are 5 major types of white blood cells: neutrophils, eosinophils, lymphocytes, monocytes, and basophils. To perform the test, a blood sample is collected either by a finger prick or in an EDTA tube. Since a normal WBC count runs into thousands, the count is made possible by diluting the sample of blood before counting and subsequently multiplying the count by the dilution factor. The dilution employed is 1 in 20. Apparatus required for doing the test: hemocytometer, WBC diluting fluid or Turk's fluid, compound microscope, cover slips, lancet and spirit swabs. Hemocytometer. Hemocytometer consists of 2 pipettes, the RBC pipette and the WBC pipette, and improved Neubauer's counting chamber. For TLC, WBC pipette is used. WBC pipette has a white bead and has graduations up to Mach 11. The size of the bulb is smaller than the RBC pipette, and the mouthpiece attached to rubber tubing is white in color. WBC diluting fluid or Turk's fluid. Each 100 milliliters of Turk's fluid contains 3 milliliters glacial acetic acid, which lyses or destroys the membrane of RBCs, 1 milliliter 1% gentian violet, which stains the nuclei of WBCs deep violet black so that they can be identified easily. Distilled water to make a total volume of 100 milliliters. Method: take WBC diluting fluid or Turk's fluid. Wipe the finger to be pricked with spirit swab. Let the spirit dry. Then prick the finger. After pricking the finger, wipe off first drop of blood. Suck the second drop of blood into the WBC pipette exactly up to 0.5 mark and dilute it with WBC diluting fluid by sucking the fluid up to 11 mark. This gives a dilution of 1 in 20. Gently rotate the pipette at least 3 to 4 minutes in the palm of the hand to ensure the proper mixing of the blood and the fluid. Prepare the counting chamber. Clean the mirror-like polished surface carefully with lens paper. The cover slip is also cleaned. The cover slip is placed over the counting surface prior to putting on the cell suspension. Expel unmixed and relatively cell-free fluid from the capillary portion of the pipette. Charge the counting chamber by allowing a small drop of fluid to form at the tip of the pipette and gently bringing it into contact with the edge of the cover slip that is already placed on the chamber. After charging the chamber, time should be given for the cells to settle down, but counting should be started before the fluid in the chamber starts drying up. Note: if the mixture overflows into the moat or air bubbles occur, clean and dry the chambers. Remix the contents of the pipette and refill both chambers. Under lower power objective, identify and check distribution of dried blood cells in the 4 corner squares. Recharge the chamber if distribution is not uniform. Set up the microscope and focus. Place the Neubauer chamber on the microscope stage. If the microscope has a fixing clamp, fix the Neubauer chamber. Turn on the microscope light. Focus the microscope until you can see a sharp image of the cells looking through the eyepiece and adjusting the stage. The squares placed at the corners are used for white cell counting. Count the WBCs in these 4-corner WBC squares. WBCs are seen as regular nucleated rounded bodies with a clear refractivity around them. Counting of the number of WBCs in each WBC square should be preferably done under lower power objective. Count all the white cells lying within the square and those touching the upper and right hand center lines. The white cells that touch the left hand and bottom lines are not to be counted. Enter your observations in the corresponding squares. Let us call this number as n. Calculations. As the dilution was done 1 in 20, so the diluting factor will be 20. Calculation of volume of fluid examined. Area of 4 WBC squares is 4 into 1 into 1 millimeter, that is 4 square millimeters. Depth of the chamber is 0.1 millimeters. Therefore, volume of fluid in the 4 WBC square is 4 square millimeters into 0.1 millimeters, that is 0.4 cubic millimeters. Calculation of total leukocyte count or total WBC count. As n was the total number of WBCs in 4 WBC squares, that is, in 0.4 cubic millimeters of diluted blood, then total number of WBCs in 1 cubic millimeters of undiluted blood will be n multiplied by the dilution factor, 20, divided by 0.4, which is equal to n multiplied by 50. Thus, you will get total leukocyte count by multiplying the total number of WBCs counted in 4 WBC squares and multiplying it by 50. Precautions to be taken while doing the procedure. Prick should be bold enough to give free-flowing blood. At no stage, fingers should be squeezed to take out the blood. Both the chamber and the cover slip should be dry and free from grease. Use only dry pipette. Never use a broken cover slip. Before charging the chamber, the fluid from the stem of the pipette should be discarded. The cover slip should be placed symmetrical so as to cover the ruled area completely. There should be no under or overcharging of the chamber. The count will be low in both these cases. After charging the chamber, time should be given for all the cells to settle down, but counting should be started before the fluid in the chamber starts drying up. The reference range for WBCs in the blood is 4,000 to 11,000 white blood cells per microliter. This value may vary slightly among different labs.